My bad.
Recording in progress.
Okay, so 2. So we get x equals 2. So, and this is the other case that I didn't spend much time over is if we have x's on both sides. So in scenarios like this, you want to use the same exact strategy. You want all the x's on the left-hand side, all the y's on the right, all the other values on the right-hand side. We never want x on both sides of the equation. We only end on one side. So an easy way to get rid of the x on this side is subtracting by 3x. And whatever you do to one side, we do to the other. And we're down to just this. 2x plus 4 equals -6. And now you can see we used to have x's on both sides of the equation, but we don't have x's on both sides of the equation anymore. And now we can use the same technique over here. Isolate x. And then we just divide by 2. Hopefully that cleared up any confusion with just solving for one variable. Are you guys good with that now? Is it clear how to solve for x? Okay, so now I'm gonna let's just try a couple practices. No, try. So yeah, I'll give you guys 3 minutes, 4 minutes, and just try to solve for x for these two. So right here. And use the same techniques we tried earlier. You want to make sure there's only x on one side of the equation, and then you want to make sure you try to make x by itself. And whatever you do to one side, you do to the other. So you can essentially remove terms. If you have any questions, you can just message me in private chat. So most of you guys did those pretty quickly. So I think you guys understand the concept with one variable. So what you do for the first one, you want to isolate the x. So you subtract 2 from both sides. You're just left with 3x equals 9. And after dividing by 3, you get x equals 3. And almost all of you guys got that one. And I'll give you guys a few more minutes, like 1 or 2 for you guys to do the second part. Well, you very good for the first one. I think everyone got that. Okay, so let's move on to the second one. We have, so some of you guys just need to be careful with your signs because that's where most of your mistakes I see are from if you made one. So let's take our 5x plus 10 equals 2x minus 2. We have x on both sides. Let's try to remove one of the x's. Let's subtract by 2x. So we only have x on this side. So we have 5x minus 2x plus 10 equal to 2x minus 2x minus 2. So this was a 3x plus 10 equals negative 2. We subtract from 10. We get x equals negative 4. Okay, so any questions for these two? If you have one, you can just message it to me privately, and I'll try to answer as quickly as possible. So now that we have this down, let's do inequalities with this. So now we have something very basic. 2x plus 1 equals 3. We could all solve this and find x equals 1, but now if we did a less than symbol, you would solve this the exact same way. There's no difference. So you just do 2x and then so you get x is less than 1. So this tells you for any x less than 1, this will be true. So we can use any of them. So let's say we try something else. 3x plus 2 is greater than, say, 2x plus 5. We'd solve these the exact same fashion. We would move this, subtract 2x from each side. Now we have only x on one side. Subtract 2 from each side. And then as long as x is greater than 3, it's true. You can solve these in the exact same fashion you solve equations, except for this. Let's look at this. Negative 5 is greater than 5. So now let's remove the negative sign by multiplying both sides by negative 1. So we have the negative 1 there. So we have x is greater than. So then we get that as our statement. So that means if x is 4, this is true, because 4 is greater than negative 5. So let's plug it in to our original. So we have negative 4 is greater than 5. But we can see this is clearly wrong. So that means there's a mistake somewhere in here. And it happened in this step. This is the only difference between inequalities and equations. So when you multiply by a negative number, this flips. So if you had a greater than, it would become this. And same thing for these. They would flip. So when you multiply by a negative number, you flip the inequality symbol to the opposite direction. So say if we had negative 2x plus 5 is greater than or equal to 11. You want to work out all the normal just arithmetic first. So you want to move this 5, subtract it. So now we're left with this. So what can we do? We can divide by -2. So, but what is dividing by -2? Multiplying by -1/2 because they're reciprocals. So we'd get x, but now the sign would flip because we just multiplied by a negative number. So this is the big change. And now just to check our work, let's try -5. Because -5 is less than -3. So -2 times -5 plus 5 should be greater than or equal to 11, which is true because we have 10 plus 5. We can see this is true. If you're ever uncertain, you want to take a number that is in the set. So you can pick any number for x that makes your final equation true and plug it into the original equation and see if you're correct. So did that clear up inequalities for you guys? Because this is the entirety of inequalities until we get to two equations. Because the last way is just how we plot these. How to plot an inequality. So after we did all that math and say we're left with x. So we take a number line. Let's just call this 5, 6, and then it just etc. It just moves on. So x is less than or equal to 5. We see this bar means that 5 is included. Whenever you have that bar that says included, you will make a shaded dot on the number that it's equal to. And then you will draw a line with an arrow, or what it's called array, in the direction that it's supposed to face of all numbers that are true. So what this is saying is every number less than 5 or including 5 is less than that, is less than 5 or equal to it, which is true. But if I took something like x is greater than 2, take my number line, point up 2, point 1, or point 3. We see there is no bar here. There's nothing. When there's no bar, you leave an open dot, which means 2 is not included. And then we need to draw an array, which shows that all numbers bigger than 2 are included. So that's inequality. So I guess we can just try a couple of equations. The graphing, I'm not going to give you a question. I just hope you understand it. So what I'm going to do is so try these out. And when you give me your answer, I want it with x all by itself. So there's nothing, no coefficient in front of x. So try these. I'll give you guys like, again, 3-4 minutes, depends. And when most of you submit the one for the first one, I'll do that one. And you can continue working on the second while I explain the first one if you got it. And if you have any questions, once again, you can just message me. For how you express your answer, you can do it with words or with a symbol. For greater than or equal to, less than or equal to, there's going to be no symbol. So in that case is, I'll show you guys in chat how I want you to write it. I want it in this form if you can't find it. And you guys did those pretty quickly, so I'm going to give you one more. There's a third question for you guys to work on. Okay, let's do the first problem. If you guys aren't done, you guys can keep working, but this one should be fairly simple. So like always, we want to isolate the x. So we just do 4x. We add 3 to both sides. And then we just divide by 4. So I should get x is greater than or equal to 4. I'll give you guys another minute for like number 2 and a bit more for 3. Okay, let's do number 2 and 3. So for 2, first we want to remove the x's so they're on one side. So let's subtract 3x from both sides. Yeah. So now we have subtract 12. And then finally, x is less than 5. So, and on to the last one, we have negative 5x plus 2 greater than 7. Let's isolate the x. And by doing that, we can subtract 2 from both sides. And now let's multiply by negative 1/5. But we're multiplying by a negative number. So we flip the sign first. We get that. X. And now just to be sure, let's test the number. Negative 2. So we get negative 5 times negative 2 plus 2 is greater than 7. Which is true because we know 10 plus 2 is greater than 7. And now let's get on to the hard stuff. So this is what you guys didn't like from last week. It's the graphing and 2 variable equations. You guys probably still remember the form. Slope intercept. So let's talk about slope. Slope is pretty much how fast or how slow the line grows. So like what slope really is for a line, it's just how much the y moves divided by how much the x moves. Like, let's call this 2, 3, and let's call this 3, 7. So what slope is every time we move to the right one, how much does the y increase? That's it. So every time you move to the right, so every time x increases by 1, how much does y change by? So we see x increases by 1 here. So the y increased by 4. So we'd have slope here would equal 4. Let's say in this case, again, let's use the same reference point, 2, 3. Let's call this 6, 1. Again, we want to look at how much the x moved and how much the y moves. So the x from 2 to 6, that means x moved by 4. But how much did y move? We see y actually decreased. So y changed by negative 2 and x changed by 4. So we get a slope of negative 1/2. What this means really is every time x increases by 1, y decreased by negative 1/2. And there's a general formula for this. So what this is saying is, this is just very fancy ways of saying how much the y moved divided by how much the x moved. So we can see, if I gave you points like 5, 2 and 9, 6, we're looking at again, how much does the y move? So first, let's label our points. Let's call this 1, and let's call this 2. So it lines up with this. So we know this is in the x position of the second number. So let's call this x2. This is x2 now. Because, it's the x value of the second number. So this would be y2. And same following that logic. And now we have what our x1 is, our y1. Now we can calculate our slope. How did we get slope for this one is 4? So what we look at is how much the y moved divided by how much the x moved. So pretty much the x moved over 1 but then the y moved up by 4. This should make it clearer. So what this shows us is x increased by 1, y changed by 4. So how much did y move? It increased by 4. How much did the x move? It moved 1. That's how we get our slope as 4. Is that better? And now let's go back to this one, what we're talking about, how we got the slope for this. So we labeled the first point 1, and we labeled the second point 2. And then we called the x coordinate of 1, x1. And this one, x2. So how you'd find the slope is you take this, you just plug it in. You see y2 is 6, y1 is 2, x2 is 9, x1 is 5. We'll get this one. It's 4, 4, 1. So now let's give you guys a couple problems to try with. Let me give you the points. So I'm going to give you a point drawn and then a point as a graph. And I can find the slope for both of them. And the formula will be right here. Okay, try these. I'll give you guys a couple minutes. So find it for these points, and for these coordinate points, the slopes. How do we decide which one is x1, y1? You're going to choose. What I would do is call the first point 1 and call the second point 2. And then use the logic we used by before. But this is the special thing about slope. It doesn't matter which one you choose as 1 or 2. You could have chosen this one as 1 and this one as 2, and you get the exact same answer. After you finish these problems, let's take a 5-minute break and let's all come back at 6:15. So now that you guys have come back, you've had your 5-minute break. Let's talk about these two problems. So for the first one, we have two ways. We can use the formula, or we can just use the strategy I talked about. You count how much y changed and how much x changed. Let's look at how much y changed. This was 1, this is 11. So y increased by 10. Let's see how much x changed. X was 0, and now this is 5. That means x changed by 5. And now if we want to use y1, x1, let's call this point 2 and this 1. Let's take the y coordinate of 2, subtract it from the y coordinate of 1, the x coordinate of 2, and the x coordinate of 1. There. And now into this one. So I label these as 1 and 2, but just to show that it works both ways, I'm going to label this one as 2 and this one as 1. So let's start. So we got y2. This is the y coordinate of 2. Take 7. We subtract it from the y coordinate of 1, which is -2. And now we have the x coordinate of 2, which is 2. And we want to subtract it from the y coordinate of 1. I mean, the x coordinate of 1. So this leaves us with 7. Double negatives means plus sign. We know this is -9. So that's a slope for that one. So do you guys understand slope now? Is slope cleared up? So now let's talk about graphing. Okay, wait, some of you guys said not really for slope. What do you not understand about slope? You can message me in chat or just unmute and say it. Well, how do you find which number is on top and which number is on the bottom? So let's talk about coordinate points quickly. So you know how we always see one number and another number? The first number is x. The second number is y. And say now we have more than one point. Let's label the first point. So now let's call this 1. So this just stands for the x coordinate of 1. This is the y coordinate of 1. And now let's take 2. And then we have the same thing. We have the x coordinate of 2 and the y coordinate of 2. And then we just subtract the y coordinate of 2 minus the y coordinate of 1 over the x coordinate of 2 minus the x coordinate of 1. So how we find out the top, what we subtract, is we just know coordinates always come in the form of x comma y. And then we just label our points. We have 2 points, let's label them. Label this as 1, label this as 2. So now we have 2 and 1. And now we look at the y coordinate. The y coordinate is always the second number. We subtract the one we labeled 2 from 1, and the one we labeled 2 from 1. And that's how we get our slope. So now let's talk about graphing. So let's talk about the 3 separate forms. Let's start with the easiest one. Slope intercept. We got to see our friend here, m, that's slope. And now we have y and x. Now we have two variables. But the only one we're actually going to try changing is x. So let me just say y equals 2x plus 3. So we know that x can be anything, right? So let's take a graph. Let's say x equals 0. That means y would equal 3. So this point, x coordinate is 0. This point is 3. Let's say x equals 4. So 2 times 4 is 8. And 8 plus 3 is 11. So we have y equals 11, x equals 4. So we take a point where the x coordinate is 4. That would be this point. And in fact, there's another point here where it satisfies, a point here, a point here. And if we keep drawing all these points, we see they form a nice line, straight line. And this line, all this line shows is every single possibility that makes this equation true. So how do we find this line? So this is slope-intercept form, the simplest form. The m stands for slope. The x and y never change. They just stand for their coordinates. And b is the point, it's called the y-intercept. It's the point where it crosses the y-axis. It's a y-coordinate. As we can see, the y-axis has an x-coordinate of 0. So the easy way to find it is we take the equation, we plug in 0 for x, and we'll get it. So are we good there? No questions? Yes. So in this case, if you want to find the y-intercept, you plug in 0 for x. So 0, okay, 2 times 0, 0 plus 3. So yes, we get our y-intercept as 3. And that's why this b is even here, because that is the y-intercept. And now let's talk about how we can find this. So let's talk about how to graph this first. Let's take any equation again. Let's try 3x plus 2. Whenever you see an equation like this is slope-intercept. What it means is y is all by itself. That's the telltale sign of slope-intercept. So how can we graph this? What we want to do, the big things we want to look at is what is the slope and what is the y-intercept. So let's take our coordinate axes. And let's start with that. Let's look at our b value. When graphing slope-intercept, always look at the b value first. So we get this as 2. What this 2 means is when x is 0, the slope y-intercept is 2. And we can test that. When x equals 0, y equals 2. So let's plot that. And now this is a linear equation. So what we can do is we can find another point. What is a very small number, but easy to use in this scenario? It's small, but easy to calculate. Yeah, 1. So let's say x equals 1 now. Now we have 5. And now, yes, Isaac, correct. We would have the point would be the x coordinate would be 1 because we chose our x as 1. And now what did we get? 5. So our y coordinate would be 5. Now that we have our 2 points, how can we finish a line? We connect the points. We'll keep going. And this is the line. And this line represents every single solution to y equals 3x plus 2. There are an infinite number of solutions to this. So, are there any questions of slope-intercept? If you guys have any questions, you can message me in chat. Otherwise, let's move on from slope-intercept. So slope-intercept is nice and all. It's very easy to understand. It's easy to graph. It's visually pleasing. So let's talk about how can we get to slope-intercept. Like say if I give you 2 points and we want to make a line, how can we get to slope-intercept form? And how we do that is we use point slope. So when using point slope, there's two cases when you want to use point slope. You have, they give you 2 points or 1 point plus the slope. You can't see that. Okay, my bad. So like I said, you need 2 points or 1 point plus the slope to use it. If you have 2 points, though, you have to calculate the slope first. So let's work with that scenario first. Let's say I have the points 1, 3 and 2, 5. So at this point, we should all know how to find the slope. Let's label this as 1, label this as 2. We took y2 minus y1, x2, x1. So we get 5 minus 3 over 2 minus 1. Okay, we have our slope now, which means we can use a technique here. So we can choose a point, any point. It doesn't matter. We got our 2 points. We don't need to choose this one or this one. We can pick one of these two. So I'm going to prove that it works by choosing any point. I'm going to do it for both of them, and we're going to see we have the same answer. And this is the formula. So this looks very big and complicated, but it's not. So let's see. This is just the slope. These are the x and y's that never change. And there's something new here. You'll see a y1 and x1. You see, but it doesn't have to be a y1 or an x1. We can do this perfectly fine with y2 and x2. In fact, let's do it with both of them and see what happens. So let's try y1. What is y1? Well, let's look at the first point that we labeled 1. How do you multiply a coordinate? What do you mean by how do you multiply a coordinate? Oh, we don't multiply like that. When we're talking about the x coordinate, we just take the number itself. Something like this. This is scalar multiplication. We don't need to know that. That's multiplying by a scalar. That would be a dilation. You get here to here. What we're doing is very different. This isn't a coordinate point. This is x, and we're taking the value. So like we're saying, the y always stays there, but we take the value. So the y coordinate of the first point. This is our first point, and this is our y coordinate. It's 3. And now let's look at our slope. We found our slope. It's 2. And now let's look at the x coordinate. This x will never change. And now what is the x coordinate of the first point? It's 1. So this is our point slope form. And now let's look at for this one. We look at the second point. The y coordinate's 5. The slope is still 2. And the x coordinate for this one is 2. So now we have our two equations in point slope. But this form is ugly. We don't want to use this. It's hard to work with. Let's convert it to slope intercept. How we convert to slope intercept is we want y all by itself. And we don't want this multiplication. We want it, no parentheses, everything multiplied out. So let's work with the first one. So first, let's multiply through. So we have 2 times x, it's 2x, 2 times -1, -2. And now this is already starting to look better, but we still want the y by itself. Let's add 3 to both sides. So this becomes 0. Then we have 2x plus 1. And now we see we have our thing in slope intercept form. And now let's work with the second equation to prove that they are the same. So let's multiply out. So it's 2 times x is 2x, and the 2 times -2 is -4. And once again, we want to add 5 so the y is alone. And we can see both these numbers are the same. So this is, if I gave you 2 points or 1 point and the slope, this is how you convert it to slope-intercept form. And we already know how to graph from slope-intercept form. So this is pretty complicated. There's one last form, and this is the form you'll see the least. This is the form you see in word problems when you're like going shopping, you're buying tickets. You're going to see it in a funny form where X and Y are on the same side. So we see these numbers A, B, and C. What are A, B, and C? They're just any number. A could be 1, it could be -5. We just get to choose. So see, I choose A, I want A to be 2, and I want B to be 3, and I want C to be 6. So now we have this form. Again, this form is hard to graph. We don't want to work with this. So what we can do is we want to convert this into, again, slope-intercept form. We can see it's always easiest to work with slope-intercept. So what we would do here, where did the 1 come from in the y equals 2x plus 1? So when you're looking here is 1. So let's look at the form in general. We have y minus y1. And we know y1 is a point. We called it here. This is 1. So this is the y coordinate of 1. So this is y1. So we do y minus y1 equals the slope, which we already calculated, times x minus the x coordinate of 1. So we get y minus 3 is equal to 2 times x minus 1, because we plugged in the y1 and the x1. And now coming over here, we expanded this. So we have 2x minus 2 and y minus 3. But we don't like anything over here. So what I did here was I added 3. So we have y plus 3 minus 3. But whatever I do to this side, I have to do to this side. So I do 2x minus 2 plus 3. This becomes y because these cancel. And this is 2x plus 1. So now you know how we got the 1? Is it clear, or was it too fast for you? Okay, so let's move on. Let's talk about standard form again. So standard form is nothing special. It's just x and y are on the same side. So last time I gave you guys a very messy general formula where we just do like c minus ax over b equals y. That's a messy formula, and that doesn't actually teach you anything. I probably shouldn't have given you this. So don't use this. You want to always work with it. So we want y by itself. But what is with y right now? There's this 3 that we don't like, and there's this 2x. Let's deal with the x first. When you have standard form, let's deal with the x before we deal with any of the coefficients. So how do we remove the 2x from this side? We subtract by 2x. We have 2x, but now we subtract 2x. But whatever we do to the left side, we have to do the right side. So we subtract 2x over here also. But what is this? This is 0. So now we just have 3y equals 6 minus 2x. Okay, so we almost already have y by itself, but we want to divide by 3, so just y. So dividing y by 3 is y. Dividing 6 by 3 is 2. And this just becomes a fraction. And the last thing to do for slope-intercept is we just move the x in front of the 2. So this is really just equal to -2/3 x plus 2. You guys got how to convert from standard form? Okay, no questions. Let's try a couple practice problems again. So I'm going to give you 2 points, 1 point and a slope, and a standard form equation. And I want you to convert all of those into slope-intercept. We remember slope-intercept. Oh, you didn't finish the notes over here? That's fine. Here. Copy that down. Yeah, sure. If you guys ever have any questions, you can just ask me in chat. I mean, I know how you guys feel. It's being confused. It happens to me too. It's perfectly fine. The formulas. Yeah, the worst formula to memorize is just this one. But for these problems, I'm going to give you guys the formula. I'm going to write the formula on the side for you. So you just need to remember what each one goes. I won't give you the name, but I will give you the formula. And for the homework, you guys have your notes, you have the video, and worst case scenario, you have the internet you can find the formula on. So remember, this is our standard form. I want the answer in this form. And now this is the point slope. And this is how you find the slope. Remember all these fancy terms. Just remember how we break them down into something simpler. Something that's easy to understand. So these are our three formulas. So the first one is I'm going to give you 2 points. Let's try 3 and 7. Let's do what's something else. Let's try 5 and 1. Okay, and now I'm going to give you 1 point. So let's give me this. Let's give you the slope. Say the slope equals 5, and I'll give you the point 2, 1. That's your next one, and then the final one is throw in a minus here. Don't be scared by the minus sign. That's what I have to say. When dealing with the minus sign, we still want the y by itself. So we'll follow the same steps. We'll remove what's with the y, and then we can just multiply by -1/2. So we can remove the negative sign because we never want a negative sign here. We want it just to be y by itself. I'll give you guys a good amount of time for these 3 problems. If when you're sending me your answer, you can just do, I'll show you guys how I want it. Again, just y equals mx plus b. So say if the equation was, this isn't an answer, but if you're going to give me an answer, I want it in that form. Nothing y all by itself, and then just x and y in a simple form. So yeah, I'll be here. If you have any questions, just ask me, and I'll try to respond to you. And if you think you have the answers, send them to me in private chat. I'm not looking for the slope as your answer, by the way. I'm looking for the standard form equation. So I want this, not the slope. Yeah, my bad. Yeah, my bad. Some of you guys are sending me slopes. No, I don't want the slope. I want you to give me the standard form equation. Oh, for the one at the end of 2, 1 for the second question, remember when I talked about you can find the equation with 2 points or 1 point in the slope? I want you to give me the equation of 1 point in the slope. So for question 1, let's go over the first step, slope. And then we're going to slowly work our way through it. I'm going to give you guys hints slowly over time. And hopefully with the hints, you can build off. So question 1, I'll give you your first hint. How to find the slope. Let's call this 1 and 2. And remember the slope. y2, the y coordinate of number 2. Because this, we'll call this point 2. Let's just look at the second number. It's a y coordinate. It's a 1. Now let's look at the first number. This is its y coordinate. It's a 7. So let's subtract. And now let's look at the x again. This is a 5. And this is a 3. We have -6 over 2, -3. So you already have your slope now. Now that you have your slope, try working with this equation. Okay, now that's been a little bit more. Let's get the next hint. I'm going to set up the equation for you now. So we have this as 1, and the equation has 1s in it, as you can see right here. So why not just use 1s? It's easier. It's less confusing for all of us. So what is a y coordinate of 1? Well, that's 7. And now m. What's our slope? It's -3. Because we just found it here. And now what's the x coordinate of 1? That's a 3. This is your second hint. Now you got to work with this. Okay, so I'm just gonna finish off question 1 for you guys now. Oh, by the way, no, 4-point slope. You do not need 2 points. you only need 1 point and the slope. But if you aren't given the slope, you need 2 points to find the slope. So let's go on to this one, and I will set up number 2 again for you guys. So let's just finish this. So we have y minus 7. We want to multiply out the -3. So we get -3x plus 9. And then that's after we just multiply out. We just distribute. And then we don't like this -7. So let's add 7. Well, we have to add 7 over here. So this becomes 0. So our answer is -3x plus 16. And for 2, you don't need 2 points to set this up. We already have the slope. So we can skip this entire step. We don't even need to find the slope. It's easier. So we just call this point 1. Y minus the y coordinate of that equals the slope, which you already have, times x minus the x coordinate of 1. So now you saw what we did here. Now try number 2 with that same technique. Expand and then isolate. Class ends at 7:30. Right? Wait, no, not 7:30. At 7.
At when?
It ends in 3 minutes.
Okay.
So yeah, so let's just do this one last problem and then we can finish up class. I'll give you guys like a couple more seconds. And finally, before we leave, after I solve this one, these last two. So first, let's expand like always. I'm just going to go through this quickly. You guys should probably get it by now. We expand, we add 1. 5x minus 9. And now on to the final question. So first, again, let's isolate y. So we have -2y. Let's subtract 5x. So now the 5x is gone. But now this is -2y. Let's multiply by -1/2. Sorry, I'm going sort of fast. We don't have much time left. We get this, and let's finally rearrange. That's our equation. Yes, it should be -9. Because we see this is -10. So we have to add 1. So we have to add 1 on this side also. -10 plus 1 is -9. It's not -11. And before you guys leave, I just have a question for you guys. I can gauge how well you guys understand it. So just before you leave, just answer this. It's just feedback for me. I can't see what you answer. And 1 is you have no clue what you're doing. And 5 is you can teach this to someone else. Yeah, 4s you understand most of it, but I mean, you're gonna be slightly confused. You might need to your notes a bit. And 5 is you're just completely fluent. You can do it without any help. Okay, well, it is 7 o'clock, so you guys are good to leave. If you have any questions, you can always just email me. I gave you guys my email, so any questions you can email me. I'll try to respond to you. And yeah, if you guys have a great week, it's summer. Go enjoy yourselves, and yeah, see you guys.